so I'm about to do number 5. Number 5 says a projectile is launched horizontally from the top of a building with a velocity of 2.7 meters per second. So a projectile launched horizontally at 2.7 meters per second. At what height is the projectile launched? So we're going to find dy this time. At what height is it launched from? If it lands 15 meters from the side of the building. So this will be our 15 meters. This time we're given dx and we're finding dy for part A. So I'm going to make my chart over here. I know, as always, my accelerations, because it's just the acceleration of gravity, which is in only a y direction. Because it's a horizontal projectile, I know the initial y velocity is 0, and that dy, whatever we find it to be, will be negative. In this case, we're finding the height of the building, so we'll end up answering the problem with it as a positive, but we still can put this here so that we make sure we remember that the object is falling downward in the negative direction. We're given 15 meters, that's the x distance, and we're given the initial velocity of 12.7 meters per second, which will also be the final x velocity since the x acceleration is 0. So now, this is the same thing as problems 1 through 3. The only difference is that this time we're using x to find time and then y to find the difference. Before we'd been using y to find the distance y to find the time because we were given the y distance, and then x to find the x distance. So same exact steps, only in reverse. We still have to find time first because we don't have enough information on the y side without it. So I'm going to use x to find time. I'm going to use that second equation that we use quite frequently. Plugging everything in, the x distance is 15 meters, the x initial velocity is 12.7 meters per second, and the x acceleration is 0. This time, this part of the equation will cancel. That 0 makes everything it's multiplied by a 0. So what we're left with is 15 meters equals 12.7 meters per second times time. To get time on its own, I'll divide by the velocity on both sides. It cancels here, so I'm left with time being 15 divided by 12.7. That gives me 1.18 seconds. So I plug that in back up here. Now I have enough information on the y side to find my distance. We could use, again, we need to use the second equation because we don't have final velocity. So I'll say dy equals the initial velocity is 0 times time, that'll just cancel, plus 1/2 of the acceleration times the time, which is 1.18 seconds, squared. To simplify this, dy equals 1/2 of negative 9.8 is negative 4.9 meters per second squared. And then I'm only squaring the time. This squared right here, it doesn't square the whole 1/2 at squared, only the time. So that will give us 1.39 seconds squared. Put that in there. So the second squared will cancel on both sides. We'll be left with dy equals the number that we just found multiplied by negative 4.9, which will be negative 6.82 meters. So what we found is that the object fell, either we could say dy is negative 6.82 meters, or we could say the object fell 6.82 meters. But that will be our answer to part A. Now part B asks for how high is the projectile halfway through its flight. So halfway through its flight, that means that it will be at half the time, and it will also be at half the x distance. So now we're talking about at this point here, halfway through its flight, how high was the object. And the reason that we can just divide the x time in half is because the acceleration was 0. So it's keeping the same average velocity throughout the entire flight in the x direction. Therefore, we can just divide the x distance in half. We can't just divide the y distance that we just found in half because this object is accelerating downward. That means it's going to cover less space in the first half of the trip than in the last half of the trip. So we need to calculate for it. To do that, I'm going to really quickly just jot out a new table because we will have some different values. Acceleration, always the same. The initial velocity, still the same. Everything here is going to be the same, other than it's now going to be 7.5 meters for the x distance. And we're going to, again, find dy. This time, we could, if you weren't positive that the time would be in half, you could find it again, but it will be exactly half of the original time because it's halfway through the flight. So 1.18 seconds divided by 2 is 0.59 seconds. So that's the time. So now I do the same exact thing I just did right here. I'm just putting in new numbers. So I'm saying dy is initial y times time plus 1/2 a y t squared. I'm plugging in just these numbers now. So we will still have, this first part gets canceled because it's 0 times time. We will still have an acceleration of negative 9.8. The only change here is that my time is now 0.59 instead of 1.18 seconds. That's the only difference. 1/2 of negative 9.8, and then over here I'm going to square the time, which will be 0.35 seconds squared. Seconds squared will cancel. I'm going to multiply 0.35 by negative 4.9, and I get negative 1.7. So in half of the flight time, it fell 1.7 meters of the 6.82 that it would fall totally.